Hello. In this video we shall show how to set up a simple unsigned adder in System Verilog and also a test bench for that. I've opened up a file called uadder.sv which has a System Verilog description for an unsigned adder. As you can see, there is the keyword module followed by the actual module name, which is u_adder, followed by the interface. The interface consists of the inputs, signals A and B, which are both of logic type and 4 bits each. Likewise, the sum is of logic type and 4 bits, and a carryout, which is a single bit here. I've created a temporary signal called temp, which is 5 bits, to accommodate the carryout. Since the adder is completely combinatorial, we have a simple always com block, and our assignments are as such. A plus B is assigned to temp, and temp 3 through 0 is assigned to sum, and temp 4 is assigned to carryout. Note they're all non-blocking assignments and within a combinational logic as such, so there is no sequential logic or any storage elements as such. That is the actual uadder. Now let's look at the test bench. The test bench has no inputs or outputs, it has to be expected. It has some local signals, and I've called them with the notation of _TB to just show that they're different than the ports. And then we instantiate the uadder, so we give the module name, the instance name, and the port list. The port list I'm doing by implicit port order here, so it essentially follows ATB is connected to the first port A, then B is sum and carry out. As such, I could have explicitly stated it, but I decided to go ahead and make it implicit for this example. And then we have our actual test bench, which is an initial block. Each module can have an initial block. It is the first block that is executed. So for here, we have 2 for loops, that are nested. We have an integer go I equals 0 to I less than 16, so go through all the combinations for A, and then all the combinations for B, and with the #10 for 10 time unit delay. I have not specified the time scale here to tell you what the units are, but we're going to use the nanoseconds as the default simulation. Okay, now that you've done both of those, let's go ahead and bring this up in Vivado. Okay. I have a session that's already running. I'm going to go ahead and close it and create a brand new one here. Exit. Alright. For this case, let me just delete my previous work. So what I did is I created a separate directory called Xilinx SV for System Verilog. Oops. Okay, I'll switch to that directory. And start Vivado there. Okay, let's go to create a new project. Note that the directory is indeed Xilinx_SV. I'll again call this project u_adder RTL project. Make sure that the target language is Verilog and the simulator is Verilog here as such. Even though we're using System Verilog, that'll be just fine as such. Let's go ahead and add our files. I have everything in the source directory, so I'll go to source. From the previous time we had VHDL code. Here we're using the System Verilog. So let's just take the design, which is uadder.sv. Next, no IP. Let's add our constraints. So there's uadder.xtc. Next. Click on boards. Our board is the Nexus 4 DDR board. And finish. Okay, there are no warnings. As you can see, the design source is this uadder. Let's go ahead and add the simulation source. So right click on add sources. Add create simulation sources. In this case, we're going to take the test bench, uadder testbench.sv. Okay, and finish. Alright, let's go ahead and run the simulation. Well, let's just make sure this is correct. So go back under simulation sources and click, and you can see that the top level is uadder underscore TB and the design is uadder, so that makes sense, right? And let's go ahead and run our simulation. Run behavioral simulation. And the waveform window automatically shows the top level signals. For now, that's okay. And let's go to our tickle command console and tell it to run for, say, 400 nanoseconds. Okay, run 400 nanoseconds. Return. Now let's go ahead and maximize our waveform window. Zoom out. And you can see, yeah, it looks like it's working, but let's double check. Let's go to right here, put a marker there. Zoom in. And sure enough, with A is 3 and with B is D, so indeed 13 plus 3 would be 16, so the sum would be a 0 and the carry would be set. Alright, so the simulation works as well. Quite simple. Okay, let's go ahead and close out the simulation by clicking it there. Okay, close simulation. We may have some issues on synthesis, but we'll find out. Click on Run Synthesis. Now, I'm running on Vivado 2016.4, so this window looks a little bit different than yours as such. So I'll be running 2 jobs at a time. Click OK. I'm going to pause the recording at this time until the synthesis has completed.